This is a project from me which I got asked to do. It's a 30 kHz transmitter and receiver circuit. The project is that the receiver is placed in a toy submarine which is submerged in water, and the range should be between 2 and 5 meters, which is between 6 and 30 feet, if I calculated that correctly. And yeah, it's a small receiver. It's 15 times 15 centimeters, or a half by a half feet place for the receiver, and a transmitter has more space where it can be used. So this is a circuit, and on the left side you see the oscillator part. On the right side you see the final amp and transmitting antenna. So there are some values double and some others are missing. This transistor in the middle, this one, is a BC548 as well. And you may wonder about the double values. Well, I've been working on this project for quite some time, and starting with big capacitors like here, like 1 microfarad, and now using 0.2 microfarads, and therefore using a big capacitor down here, which is 100 nanofarad instead of 10, and a 1.2K instead of 4.7K. Both values will work. So there are two capacitors, C and Cx, and they're both having different jobs. Meanwhile, C is blocking the RF from the antenna going to the modulator transistor up there. Cx has the job to get in resonance with the antenna. It says Raman antenna, but that's basically a loop antenna, as you can see, physically wound with 4 meter or 12 feet long wire. Okay, so remembering that it's not 30 feet range, it's in the range of 6 to 15 feet. That's the range. 6 to 15 feet, that's the range this transmitter should handle. Anyway, so let's get back to the circuit which I built here. And here you can see the fingernail clipper. You can cut your fingernails with that, cooling the modulator transistor. I was really in a hurry when I built this, and it's working. But let's get back to the circuit for those who want to rebuild it. So we have a standard astable oscillator circuit here with two transistors. With the 10K potentiometer you can align the frequency. This resistor, this 10K below the potentiometer, is wrong. It's a 33K in my project. You can see it here. Orange, orange, orange is 33K. And yeah, well, this is a experimenting around project, so this is why it's a little bit messy. And this oscillator follows into a two-stage driver. If you measure on the collector from this BC548, which is in the middle, with the 1K resistor where the 100 nanofarad is, if you disconnect the 100 NF and measure that with an oscilloscope, you will get a nice looking square wave signal. This transistor drives another transistor, which then drives the RF530 final amp MOSFET. You probably would use a better AB amplifier here, but I was just lazy and wanted to get it to work, and so I was using just one transistor. So then it makes a magnetic field using the antenna, electromagnetic field, which is then transmitted and being received with a farad bar antenna by the receiver, which schematic you will soon see. As you can see also here, for the potentiometer I've tested 10K and 50K. Both values work really well. So this is the transmitter part of a transmitter. On these capacitors, for C I'm using 1.7 nanofarads, and for Cx I'm using 1.5 microfarads. For C I'm using 1.7 microfarads, not nanofarads, and for Cx I'm using 1.5 microfarads. But actually, if you have an antenna, you want to measure the inductivity and calculate with a resonance calculator, calculate out which capacitor is needed. This is just thrown together, it does its job, it is working, and also in the German video part I'm saying to the person for who I made this, I'm saying that this is something that you can work with. You should not, or you can use it, but you rather should work and improve it. It's just like a basic circuit that is working, but can be improved. Now let's go to the receiver. On the receiver part, I'm using a complete circuit. It's not a superhead circuit, it's a straightforward receiver, means the received frequency is not mixed with another frequency, it's just passed through. And here we have the input, and here we have the input amp, here we have the antenna, and back in time I was using 2.9 millihenries, and now I'm using 1.95, and these are both calculated capacitors to get in resonance on around 30 kHz. And here is a two-stage amplifier, and here is the 10K and here is the 1 megaohm, but I was using 4.7K and 470K in my latest circuit. That's why I wrote it down on both transistors. The output from the amplifier goes to a demodulator diode, which then feeds the final amp, or better, driver, working point, and final amp. This one's a BC558, and there was something else I forgot. Well, never mind. When I find it, I'll tell you. So most capacitors here going from base to ground are shortening out the 30 kHz signal. This one's a little bit big. In my actual circuit I'm using 10 nanofarads, not 100. So this is one of these standard AB audio amplifiers that you will find 1,000 times if you search for them. And I'm using special values, as you can see here, and this is two 470 ohms in series, and this is 100K and 47K in series. And so you end up with a circuit like that. So it's working, and this one's supplied with 9 volts, as you can see here. And here is the Hcc circuit, because I had a problem when I was getting close with the ferrite antenna, when I was getting like 1 feet or 2 feet close to this antenna here. What happened then is it got really, really loud, but going away 3 or 4 feet, it got rather silent. And so I had to hit this Hcc circuit. It takes the signal here, converts it into DC pulses. This capacitor here is for shortening out the RF, which is left over. Then the DC pulses drive this transistor here, which charges this capacitor and lights up this LED that tells you, hey, there is a signal being received. But it only will light up if the signal is strong enough. And then the output from this goes to the BF245 via this R1. So this R1 defines the gain. Because if there is a positive signal from this transistor coming to R1 and going to the gate of the BF245, what happens is this amplifier circuit will decrease its sensitivity. And so you get a relatively constant signal. Means if you take the receiver and get close to the antenna, it's not going to be very, very loud in the speaker. It's going to be very loud for like a half second or even shorter, and then it will stabilize to a nice, good listenable volume. And the same thing is if you go away from this antenna. Here's less voltage, this one will make more gain, and then it will be able to receive the signal again. So it's working once again. There are sure some improvements that can be done. R2 is a fixed resistor here, it defines the volume. If you add a potentiometer here, you can adjust the volume. But since, after my knowledge, as I picked it up, it's meant to be a circuit that is just for showing somebody and not really using it later, I just threw in a fixed resistor. And yeah, okay, so it's working. Once again, there sure can be done some improvements. For example, this is a power transistor, BC161, in a metal case. I was using this because it just laid around. I was looking for a BC557. I knew where I have them. I didn't want to take them out, and so I just took this one, threw it in, and it's working. So usually you would rather use something like BC558, BC557 here. And also I forgot to mention on the transmitter side, you can play around with the transistor. You can see this ceramic disc capacitor next to the blue one, the brown one, and this one's going from the TIP122, it's going from the emitter to ground. Also helps to reduce RF noise, or better, to stabilize the circuit. But 100 nanofarads, we are talking about 30 kilohertz here. 100 nanofarads is a little bit low, it's a little bit too weak. You rather want to use 220, 330, or 470. But hey, once again, I was using the parts that were laying around. So on the transmitter side, this one's going here from emitter to ground. And about this inductor, I'm using 150 microhenry, which is way too low. But without inductor, it won't work. It will only get hot. The transistor will get hot and audio is distorted because this inductor filters out the leftover RF from the antenna, because there's lots of RF coming into this transistor. And the problem why I'm using 150 instead of 390, which is going better, or I think 1 millihenry would be even more better, the reason is very simple. I was plugging in one small coil, you know, these resistor-like coils, and let it on like 1 minute or so, and somewhere it kind of smelled weird, and I touched the coil, touched it, and it was really hot. So depending on how much transmission power you align, you can align the transmission power here. Depending on how much power you align, you will need a coil that can handle quite some current. And this one's rated at 1.6 amps, and this is why I threw it in. And yeah, this diode here is not a 1N4148, but I still write it in there because it does work with 1N4148, and this is a UF4007, which does the same job in this circuit. Okay, talked enough. Let's power up this circuit. Still, keep in mind we are having a very low frequency here. We are talking about 30 kilohertz, which is nearly something that you can hear. I mean, you can, if you're young, you can hear 22 kilohertz, and we're having 30 kilohertz here. One thing is it's not hi-fi, as you can imagine, and the other thing is the range is not that good. Of course, you can experiment with antennas, but guess what? I was having 12 feet of wire laying around, and I was too lazy to take my cardboard boxes, put them away, and get some longer wire. Just I took what I was laying around. So I'll start the cassette here, which is a German audio book, if you want to call it like that, rather vintage. Of course, Night Rider again. And then I switch on my power supply. I switch on the output, and currently it's drawing nothing. Oh, it was switched on. I just unplugged it. So we are having 12 volts at 0.16 amps, but as you can see it's rising. If you wait, as you can see it's rising, and this is something that is still a little bit tricky in the circuit because these 100 nanofarad blocking capacitors are getting too small. This transistor heats up, makes more RF power, makes the transistor more heat up, makes even more RF power, and then it will always increase the current. It will stabilize somewhere around 220 to 30, but yeah. Okay, so if you want to build a 30 kHz transmitter and receiver, this is a circuit suggestion by me. Okay, here we have the antenna, the loop antenna, which is just some wire around the cardboard. And if I go to my bed, this is 12 feet. If I go to my bed, here I have the receiver with a small speaker, and you can see how messy this is. Once again, this is just throw it together, do some experiments, get it somehow working, and make a video about it. So I connect it, and the first thing that happens is that the LED goes on, but it goes out else also because the signal is not strong enough. And another thing is, on 30 kHz you have lots of EMI. The switch mode power supply from your smartphone charger can interfere with it, the LED light can interfere with it. So there is lots of static on 30 kHz. But there we go.
Dann kommt Michael mit Julio im Rollstuhl um die Ecke geschlittert. Platz da! Platz da!
Hallo Michael.
Hallo Schätzchen!
Hallo Julio.
Hallo!
Ich habe dir noch gar nicht Danke gesagt.
Hey, das war doch keine große Sache. Das ist okay. Wir alle danken Ihnen sehr.
So as you can see, and could hear probably, the receiver and transmitter circuit is working. So this is the project, 30 kHz transmitter, 30 kHz receiver. Best regards, Stefan.